Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG and other competitive exams. If you are interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. Okay, so today we will keep it as the last lecture for point charge things, and we'll see how it goes. Okay, so question number 29. So let us say we have 2 point charges at points A and B. Let the charge over here is Q1 and let the charge over here is Q2. Fine?
Yes.
The charges are placed at a distance of A from each other. Okay.
Yes.
First, I will find the null point. Okay, and these two are positive charges. So find the null point. We have done this previously, right? So basically, null point will be between the charges. Null point is nothing but the net electric field over there should be equal to 0.
Yes.
Right? And if null point is at a distance of x away from charge q1, how much will I get x as? X is equal to A divided by 1 plus under root of q2 by q1. We have already derived this one, right? In our previous lectures. Now, so this is just the null point. Let me draw a line perpendicular to the line joining charges. Okay, perpendicular to the line joining charges and passing through the null point. Just for fun. Okay. If he says next, so this is A part, next B part. Find electric field at a distance y on the line perpendicular to AB and distance y from null point on the line perpendicular to AB. So what I mean is, let this distance be y. So this point is a point at a distance of y from the null point, and it should be on the line perpendicular to AB.
Yes.
Is this clear? So let us say this point is C. And we already know how to do this. We have done questions on this. So I will be a little bit faster over here. So most important thing I told you, irrespective of how many questions I will solve, I will always go for drawing a figure, right? So the electric field due to charge Q1 at point C will be E1 in that direction. The electric field due to charge Q2 at point C will be E2 in this direction. So A part answer is this. B part answer, we have already solved this. The net electric field is equal to
If you remember, let this angle, correct, let this angle be theta 1 and this angle be theta 2. E1 cos theta 1 minus E2 cos theta 2, I cap. Why E1 cos theta 1? Because electric field E1 is at an angle theta 1. So its component along x-axis is E1 cos theta 1. Similarly, minus E2 cos theta 2, I cap, plus E1 sin theta 1 plus E2 sin theta 2, J cap. So let me draw that triangle over here. So this triangle looks something like this, where this distance is x. Obviously, this becomes a minus x, correct? And it is given that this distance is y. So now I know the hypotenuse of this smaller triangle, x square plus y square. It is that x only. Yeah. See, now, right now in this lecture, I will not substitute it because substitution is not a big problem. So you can do the substitution by yourself. That's not a big deal. Okay. So in terms of x, let us see till where we will go. And I don't want to make it complicated. Okay. But the x value that we have is that one. Okay. What is the hypotenuse of the bigger triangle? Square root of whole square plus y square. Fine. Now, therefore, I will write electric field E1 magnitude will be what? J. Perfect. Similarly, electric field E2 will be then we have sine theta 1. See, what is theta 1? If this angle is theta 1, this angle is theta 1, right? Similarly, this angle is theta 2. Right? Yeah, tell me, what is sine theta 1? X square plus y square, right? Cos theta 1 is adjacent divided by square root of x square plus y square, right? Similarly, in the bigger triangle, y divided by a minus x whole square plus y square, and cos theta 2 is equal to a minus x adjacent upon square root of a minus x whole square plus y square. Fine. So we will substitute this and therefore we'll get electric field E bar at point C is equal to E1 is KQ1 cos theta 1. So I'll get an x also over here, correct? Due to this x square plus y square whole to the power 3 by 2. minus E2 is KQ2. In cos theta 2, I have Y. Sorry, I have A minus X. A minus X. This is A minus X divided by A minus X whole square plus Y square whole to the power 3 by 2. And this entire thing is I cap. Plus E1 sin theta 1 is this into this, right?
Yes.
Say KQ1Y upon X square plus Y square whole to the power 3 by 2 plus. Yeah. We have E2 sin theta 2, the multiplication of these two. So we have KQ2Y upon A minus X whole square plus Y square whole to the power 3 by 2 J cap. Is this clear? Now understand one thing. We have already done electric field lines. If you remember, the line perpendicular to AB and passing through null point is nothing but equatorial line. So eventually when you will substitute your x over here, this entire thing will become 0. Do you remember those field lines due to two positive charges? The field line will go like this and this field line will go like this. And the field line along equatorial line will be in the upward direction. Clear? That means the electric field on equatorial line, the electric field along x direction should be 0. Correct? And the electric field will completely be in the y direction, right? The electric field will be completely in the y direction. That means in the x direction it should be 0. In the x direction, see, in the x direction, it is completely 0. The entire electric field will be in the y direction. And Ey cannot be 0 because there is a positive sign here. The only possibility is Ex can be 0. And if you actually substitute, you will eventually result to this one. But we already know this in field lines also. The horizontal components of the field lines will cancel each other on the equatorial line. And we also discussed that this is a plane in itself in 3D perspective. Is this clear? So eventually the entire electric field at point C, after I substitute all those things, I will get it as what? Ey j cap. Correct? Entire electric field at point C will be this entire Ey j cap. That's all it is going to be. Is this clear? We will solve a simpler version now after this. Okay? But first you take this down. Okay? Okay. So now we will solve the simpler version of it. And in simpler version, it will be easier for you to figure out, that the horizontal components cancel each other. Okay?
Yes, sir.
So let us jump into question number 30, right? Fine. So simpler version is simply take two identical charges, charge Q1 and charge Q1 on both sides at a distance of A from each other.
Yes.
Now, what was our first thing? Our first thing is find the point where the net electric field is zero, right?
Yes.
Find the point where the net electric field is zero. Where are we finding this? On the line AB itself. We said let the distance be x. So we got x is equal to 1 upon 1 plus Q2 by Q1. They are both same charges, so they will cancel. It will be 1 plus 1 is nothing but A by 2. Correct?
Yes, sir.
This is A upon 1 plus under root Q2 by Q1. And this is nothing but same charges, so it will be 1 plus 1 and eventually A by 2. That means we do know that halfway through the line AB, we will have the null point. Correct? Now the second part. At a distance of y from the null point perpendicular to the line AB. Let us say we have a point C, correct? So in the B part, we said on a line perpendicular to AB at a distance of y from the null point, find the electric field, correct?
Yes,
So
sir.
simply I will write over here, find the electric field at point C. Fine? So we will see how we have done that in the previous one. This is B bit. E net is equal to. See, because the charges are same, we got the distance as same. X is A by 2. That means this distance is also A by 2. That means this is a isosceles triangle. ABC is an isosceles triangle with, we can't say theta is 45, but we can say it's an isosceles triangle where the sides AC is equal to BC. Yes. So if this angle is theta 1, this angle is also theta 1.
Yes.
Also, the distance AC is equal to distance BC, correct? Hypotenuse. By figuring out this much, we can definitely say that if the electric field due to charge Q1 at point C, if it is going to be even in this direction, then the electric field due to the other charge Q1 at point C will also be even, but in different direction, correct? And we just now figured out that the angles are going to be same, correct? So like we said earlier, we had E1 cos theta 1, correct? Minus E2 cos theta 2, I cap. Fine? because theta 1 is equal to theta 2 and E1 is equal to E2, we won't have x component at all. Here it is very evident. Plus, other thing what we had, E1 sine theta 1 plus E2 sine theta 2, correct?
Yeah.
And this is J cap. Is this clear? And we know because E1 is equal to E2, and here we are saying both are even only, right? And thetas are also are same. So theta 1 is equal to theta 2, which is theta 1 itself. I can clearly say that the resultant electric field will be 2 times of E1 sine theta 1 in the j cap direction. Correct?
Yeah.
So let us see how much it is. So 2 times. What is E1? E1 is K Q1 divided by hypotenuse. Right. We can say a square by 4, which I am writing as a by 2 whole square plus y square. Correct? Under root of a by 2 whole square plus y square is the hypotenuse. Here I will get a by 2 whole square plus y square. That's it. Right?
Yeah.
And in sine theta 1, in place of sine theta 1, I'll have opposite by hypotenuse. Correct?
Yes.
Opposite is nothing but y upon hypotenuse. Right. So a by 2 square plus y square under root. Correct? This is all in the direction of j cap. Entire resultant of EC bar will be along j cap. Fine. So therefore, EC bar is equal to 2kq1y upon a by 2 whole square plus y square whole to the power 3 by 2 j cap. Is this clear? Easy.
Yeah.
In the previous one, if we substitute x, it will become big, but eventually it will cancel because we know it from the field lines concept, correct?
Yeah.
But here we can, by simply simplifying and taking the details easier, here we can easily figure out that it is entirely towards j cap and there is no electric field along I cap. Is this clear? And because both are positive charges, this is also positive charge plus Q1, this is also positive charge plus Q1. So the resultant electric field on the equatorial line is in the upward direction. Clear? Xerox. I hope everything till here is all clear, right?
Yeah.
Now, I want to discuss in the same question the part wherein I want to see how the force will be there if there is a force applied. If there is a charge that is placed, simple, correct?
Yes.
So basically, the C part is basically I want to find the force. So the entire story is the same. I have 2 point charges Q1 and Q1 at points A and B. Now we know that because the charges are same, the null point will also be at the center, right? If the entire distance between AB is A, then the distance between A and the null point is going to be A by 2. Now at a distance of Y above the null point, we said there is a point C where there is net electric field. We set it is EC bar, which we wrote just now. We know what that electric field is. If I place a charge Q having a mass M at the point C, okay? If we place a charge Q having a mass M at point C, now what will happen? There will be an electrostatic force. There will be an electrostatic force in the upward direction. And because mass is also given, I will have to consider gravitational force, the downward direction. Is this clear? So, if point C is equilibrium position or equilibrium point, that means if there is an equilibrium existing on the charge Q that is placed over there, that means my electrostatic force should be equal to my gravitational force. If the point C is an equilibrium point, then my gravitational force mg acting in the downward direction should be cancelling the electrostatic force that is acting in the upward direction. What is the magnitude of electrostatic force? We already know it. We wrote it just now. 2kqq1 y upon a by 2 square plus y square whole to the power 3 by 2. And this should be equal to mg, which is the gravity. Is this clear? Okay. Fine. There is further something that I want to discuss. So this situation till now, whatever we have discussed, is basically condition for equilibrium, right? Whenever we say that there is equilibrium, that means the net force acting on it is 0. So here if I am saying that the upward force is equal to the downward force, that means that is an equilibrium point. And therefore I am getting this electrostatic force is equal to the gravitational force. Correct? Is this clear? If you remember, for equilibrium positions, we discussed something called stable equilibrium or unstable equilibrium. So simply there is a point charge Q1, and here I have a point charge plus Q. These two charges Q1 and Q1 placed at A and B are fixed charges. Charge at point C can move, is a free charge, it can move. So the question is, will the charge placed at point C Will it be in a stable equilibrium or unstable equilibrium? So I will discuss this. I will discuss this. So let us draw a new figure. Okay.
Yes.
So how do I figure out if the equilibrium position that we have over here is a stable equilibrium or unstable equilibrium? You remember that bowl example, right? So what do we do? Here we have to move the charge slightly and leave it. So if I move the charge with a small displacement dy or delta y, now tell me which force is decreasing, which force is increasing. Is the gravitational force changing? Will remain the same. So I don't have to bother about mg. Now, will the electrostatic force as we go away from the charges, will it increase, decrease, remain? Because the distance is increasing, the electrostatic force will decrease. Correct? That means when I go at this particular position, at that particular position, I will have mg which is greater than my new electrostatic force Fe dash. Right? Y plus delta y. Correct? I will have a new electrostatic force. And if I go above, I know that the gravitational force will be greater than the new electrostatic. Is this clear? So my resultant force will be what? Gravitational force minus new electrostatic force, right? And this resultant force direction will be what? Downward direction. Is this clear? So let us rinse and repeat the story again. We came to what is the null point. Then we said let us go at a distance of y above it and find the electric field. We found the electric field. We made everything easy, same charges, thereby we got an isosceles triangle situation. Thereby the entire electric field is anyways along the equatorial line, right? Now we can all see what that electric field is, and if I place a charge plus q at the point C, I can also write what that electrostatic force is and the direction of this electrostatic force is in the upward direction. Here we have also given mass m, right? So we are considering gravitational force also. In question, he will not tell you consider gravitational force. He will give you mass. It is upon our common sense that we have to consider gravitational force. Then we said if this point is equilibrium point, if that happens, my upward force should be equal to the downward force. Therefore, Fe should be equal to mg, therefore blah blah blah. Correct? Now, once I said it is equilibrium point, I am interested if this is a stable equilibrium or an unstable equilibrium. So, to check if it's a stable equilibrium or unstable equilibrium, as human beings, what do? Poke it. You don't know what is happening on Mars? Poke it. I want to know. One day, I hope one day aliens come And when the aliens will come, I want to see the faces of Putin, Trump, all these people having fun. One day, if highly, evolved species from outside will appear. Seriously, and this is not the recent desire that I have. Long desire. I'm waiting for it. I hope before I die, one alien shows up. Yeah. So, coming back, as we humans are interested, if I want to check if this is a stable equilibrium or see, think of this. The alien will come. Is this alien a stable fellow or unstable fellow? Poke him. Poke him and see. Entire human race will be wiped out. So, what do? Shift the charge by a distance, small distance, and leave it. And see if it will come back to the same position or not, right? To know if it will come back to the same position or not, I have to study the forces that are exerting on them, on the charge again. So now you already got used to the fact that how to study force is to study electric field multiply you get the force, right? So as we go farther from these two charges, you already figured out that the electric field strength will basically decrease. Therefore, the electrostatic force acting on it will also decrease. Therefore, Fe dash is less than the gravitational force over there. Therefore, there is no change in gravitational force. Only change that occurs is basically electrostatic. Correct? And we figured out that the gravitational force is greater than the new electrostatic force. The direction of gravitational force and the direction of new electrostatic force haven't changed. They're still the directions are the same. Magnitudes have changed. And the two magnitude of Fe dash has changed. Electrostatic force has changed. Right? Now, if mg is greater than Fe dash, then the resultant force will be directed in the downward direction. And the magnitude will be mg minus Fe dash. Mg is constant. But what we are saying is there will be a gravitational force in the downward direction.
Yeah.
And there will be a new electrostatic force in the upward direction. Fe dash. Now what we are saying, the resultant force will be what? Mg minus Fe dash in the downward direction. Resultant force. So what are we overall from this information? What are we grasping? If you give a displacement dy in the upward direction, the resultant force acting on it is in the downward direction. So do you remember? If the resultant force is acting opposite to the displacement, stable equilibrium. Since F net, okay, or F resultant, okay, and that too dash I will put. So since F resultant dash vector is anti-parallel, correct?
Mm.
Is anti-parallel to the dy bar displacement vector, we can say that it is a stable equilibrium. Is this clear? Understood? We can say it is a stable equilibrium. Fine? I'm still not done. There is something tiny but important point over here. So we got what the force is, and if it is an equilibrium point, we got how it is equilibrium, upward force is downward force. Because we are talking of equilibrium now, I am interested if it's a stable equilibrium or not. We figured that also. Correct? Now I want to know the nature, exact nature of this stable equilibrium. Okay, I am telling. Okay. So if I study my f dash resultant vector thoroughly, what am I getting? I am getting it as mg minus fe dash, right? What is fe dash? New electrostatic force. What is new electrostatic force magnitude? Let us write it separately for our understanding. The new electrostatic force Fe dash. See, what is the difference? There is no difference. Earlier it is at a distance y. Now it is a distance y plus dy. So simply it will be this one y plus dy. So what will we come out as? 2kq1. In place of y, I have y plus dy. Correct? Divided by a by 2 square plus y plus dy whole square. Correct?
Yes.
But remember, when I am doing, on one hand, I am doing a by 2 whole square, and on the other hand, I am doing y plus dy whole square. Dy is very, very small. Dy is very, very small. Correct? So basically, in front of a by 2 whole square, if I write y square or if I write y plus dy whole square, it will more or less look the same. Is this clear?
Yes, sir.
So I am going to write this as y square only. We will come across this situation. We can use binomial expansion, and we can do this as a plus b whole square, right?
Yes.
So we will get a square plus 2ab plus b square. And that way also we can figure out the same thing, that dy is way less compared to y square. And dy square will be definitely less compared to y square. So I can let go of that entire thing. So that's why I just mentioned it in short, that when I have y plus dy whole square where dy is very, very small and we have a square of it, I simply can write it as y square.
Yes.
The best example that I give over here is, what is 9 square? 9. Now what is 9.000001 whole square? Are we going to open calculator? Are we going to open calculator for that? We will say it is almost 81 here. Come on. Right?
Yes.
The same concept, instead of what you said is right, we should actually do a plus b whole square, and that is how we explain in our binomial thing. In physics also we explain the same thing, but here, I don't want to complicate it much. It's a very easy thing. Whenever I have a square, a cube to the power 4 or anything, and if I have y plus dy, I can take it as y square because of this example. That's why here I am writing it as y square rather than y plus dy whole square. Is this clear? Therefore, when I substitute over here, my new resultant force, F dash resultant, will be mg minus the Fe dash. What is Fe dash? 2k q1 y plus dy, correct? Divided by a by 2 square plus y square whole to the power 3 by 2. And this entire thing is in which direction? Minus j cap. But my gravitational force mg is equal to this 2k q1 y by so on and so forth. Right? So if you look at it over here, I can write this as mg minus. If I write this one term first, 2k q1 y upon a by 2 square plus y square whole to the power 3 by 2. That means what? Instead of y plus dy, I am first writing y, then I will write dy. Minus 2k q1 dy upon a by 2 square plus y square, the entire thing whole to the power 3 by 2. And this entire thing comes under minus j cap, right? Is this clear?
Yes.
Understood? Fine? Yeah. Correct. So basically to show you that this entire thing will cancel with the entire thing. Mg minus, I just opened the brackets, right? Y plus d. I just opened the brackets of y plus dy. Is this okay? Is it clear? Understood? See, simply what I'm trying to say is that my f dash resultant vector is proportional to, because everything is getting cancelled, and here all these things are constants except for dy, right? My f dash is proportional to minus of dy vector. So when I said that we are going to study the nature of this equilibrium, the nature of this equilibrium, simply whenever f is proportional to minus dy, we write it as SHM, right? Simple
Yes.
harmonic. Is this clear? Understood? If you disturb it once, it will do a simple harmonic motion. If you slightly disturb it, it will do simple harmonic motion. Is this clear? So that's why I wanted to discuss it, because eventually we are coming into SHM. Yeah? Mm-hmm. Push it downward, then it will go upward. If you push it upward, it will come downward. That's why it is stable equilibrium, right? And it is going to do SHM. If you push it anywhere downward, upward, only along downward, upward, it is going to do SHM. Clear? Xerox. See, actually, when I am doing downward force minus upward force itself, I should not have minus j cap over there. I am already writing down minus up, right? So that's why minus sign will come automatically. I don't have to put it again. No, it will do SHM. Minus sign is here. I don't have to mention minus j cap because I am doing mg minus this already, right? Otherwise, minus into minus will become plus. So let us look at the last part of it. So you figured out how we are deriving it's a stable equilibrium and it's a simple harmonic motion, right? So in any question where it is SHM, we just have to draw the free body diagram, identify the forces, write the magnitudes, and ultimately, if it's an SHM, we have to prove that F bar is proportional to negative of displacement vector. Okay. So, like you said, once we have simple harmonic motion, then that fellow will ask me time period. Correct? So, my ultimate aim was to reach over there. So understand it very carefully. If mass m is doing SHM, then what should I get the forces as? I should get the forces F bar as proportional to minus of some displacement vector. If this F bar is equal to minus some constant times the dy vector, displacement vector, we get something as angular frequency omega, or you can say frequency, but frequency comes out as different. So angular frequency omega, you can write it as under k. Correct? Is this clear? So keeping this in mind, also final thing, the time period, if that fellow will ask, you will just do 2 pi by omega. Correct? So in our example, for our problem number 30, so this is a concept. For our problem number 30, if I want to write that constant, how much is that constant going to be? 2kq q1 upon a by 2 square plus y square whole to the power 3 by 2. Is this clear? So therefore, from here I can get my omega as under root of this entire thing divided by mass.
Yes.
Correct? So this entire thing divided by mass. So 1 upon mass into the constant is 2kq q1 upon a by 2 square plus y square whole to the power 3 by 2. And this entire thing whole to the power 1 by 2 is my omega. Is this clear? Under root of the entire constant divided by mass is my omega. And once I get omega, my time period is 2 pi by omega. Is this clear?
Yes.
Xerox.
Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.